transmit at the same time on the same channel because some APs are physically separated far enough. So in the downlink, in transmissions coming from the infrastructure out to the client, it actually allows simultaneous transmissions when it knows that those transmissions wouldn't interfere with each other. And we can basically define up to 3 regions like that. So you could actually get 3 times the bandwidth. Okay. So just quickly summarizing the advantages here, and one I haven't mentioned yet is it's really simpler planning of the network. Because the centralized switch eliminates co-channel interference entirely, you really only have one variable to design for. All we have to do in the Extricom system is make sure that there's continuous coverage. It doesn't matter if adjacent APs are overlapping in their coverage area by quite a lot. In fact, that overlap is used as an advantage in our system. In the other microcellular system, having too much overlap is a problem because it causes interference between adjacent cells, and it actually reduces performance. So anyway, that's a simplification. Another simplification that we don't talk to about very much is, in a way, you can add an entire wireless LAN by just using 1 gigabit Ethernet port on the wired network. You know, you take that one port from however the wired network is configured. You have one port, 1 gigabit port, plug it into the back end of our switch, and then our switch connects to all of the APs, and voila, you have an entire network coming out of one port. So it's conceptually, it's much simpler. You don't have to worry about reconfiguring VLANs and tunnels and so forth. You can leverage the same VLANs that you already have on your wired network. I mentioned the system level diversity already. That's that concept of every transmission from a client is heard by multiple APs. Within the channel blanket, we don't have any handoff at all, so there's no reassociation. But in particular, if you're using security, part of the reassociation process means reauthentication, typically. And this can cause a noticeable delay. And if you happen to be using a voice application, it might be, in fact, a drop call because it takes so long. Now, there are optimizations for this. There's a fast roaming protocol that's being standardized. But within a blanket, we don't even need to worry about that. We would apply that roaming protocol across multiple blankets if we had a very large installation. We talked about the multiple layers. You get multiple wireless LANs in the same infrastructure. The other thing is, within the channel blanket, everywhere in the channel blanket, you're getting a very high-power signal. In Wi-Fi, what that means is you're transmitting at the maximum data rate. The normal behavior for Wi-Fi clients is when they're very close to an access point and getting a very strong signal, they operate at the maximum data rate. As they move farther away from that access point, the signal may degrade, and the way the client deals with that is it drops into a lower data rate where it can operate without error more effectively. And that happens automatically. It's built in every client. In our case, that typically doesn't happen very often because the coverage, you have this redundant coverage, if you will, and so typically one of the APs can always give you a very high data rate connection. So it's a very solid connection throughout. We're going to talk about 802.11 now, so I'll get to this smooth transition as we go into those slides. So let's move on, Dan. So one of the big developments in the wireless LAN world is 802.11n. It's actually a technology that's been around for several years. It's taken a very long time for the standard to be completed. It was just ratified in September of last year. And but the chip level technology has been available for really 2 or 3 years by now. And the good news is that it's a mature technology in that sense, and really the chip at a chip level, they're already on 3rd and 4th generation chips for this. But in enterprises, some people were holding off on 802.11 deployments until the standard has been ratified. So now we're finally past that hurdle. The standard was ratified. The Wi-Fi Alliance is certifying products, and indeed the Extricom wireless LAN infrastructure is Wi-Fi 802.11n certified. So this standard is the biggest change that's happened in the wireless LAN industry. It changes everything. It changes the physical layer, the radio, the antennas, the modulation, and it changes the software, the MAC protocol, and many other aspects of the software. And the benefits that we see, coming out to the end user come from a variety of different technologies. Let's move on and get into some of the features here. So I mentioned probably the biggest and most exciting change is something called MIMO. Stands for multiple input, multiple output. It means multiple radios and multiple antennas for both transmit and receive. So the common configuration for enterprise class 802.11n right now is 3x3 MIMO with 2 streams. So that means 3 antennas for transmit and receive, and you actually have 3 radio receive chains, front ends. And what 802.11n is doing is it's actually transmitting multiple things in parallel, and then using very complex signal processing, it is actually combining those multiple signals into a higher data rate signal. And it's really a tremendous benefit. Many of the other things have also, the other thing is you can transmit multiple streams at the same, so you have multiple antennas that are getting multiple copies of each stream, and then you have multiple streams that are being transmitted at the same time. Another thing is just the raw quality of the radio has improved, just based on advances in the chips, but also in tightening up the spec and standard. The low-level modulation improved. We were using OFDM before in 802.11g products and getting 54 megabits raw data rate in a single 20 megahertz channel. Now that's been bumped up to 65 megabits per second. You can even combine 2 channels together, do channel bonding, and get a 40 megahertz channel that doubles your data rate. And then from a software point of view, there have been a number of optimizations to the MAC protocol that allow it to go faster. Probably the most significant one is something called frame aggregation, which allows you to effectively stream out a train, several packets in a row, and then only acknowledge the entire train of packets, if you will. You could send out 8 packets and just have 1 ACK. That really reduces the overhead, makes the protocol more efficient, and fundamentally allows you to deliver. Makes it more efficient, allows you to deliver more real throughput from that data rate. So the products that are shipping today in the enterprise are 300 megabits raw data rate, and you get about, if everything is perfect, you might get 160 megabits of real throughput measured at the TCP/IP level. So it's pretty good. And there's going to be another speed bump coming maybe in the next year or 18 months. Where we add in another stream and take it to 450 megabits of raw data rate. Another thing about 802.11 is it supports both of the bands, 2.4 and 5 gigahertz, and that essentially opens up more channels that are available to you. So how are we doing with 802.11n? Did we get the high throughput? Yes. I mean, with the previous system, 802.11g, we were getting about 20 megabits, maybe a little bit more, out of a 54 megabit per second raw data rate. And now, as I said, we're getting about 160 measured the same way out of a 300 megabit channel. So it really is an improvement in the throughput. Now, in order to get that, you have to turn on every one of these new features. But the other thing that's not talked about so much is really the improved robustness of the system. The range is better and the coverage is better. And everybody experiences this. 11N products are available now in your home. You can get a Wi-Fi router from Linksys or from Apple, and plug it into your cable or DSL in your house, and you can see the improvement. Your older Wi-Fi gear that might have been 802.11g still operates at its maximum data rate, but it might do that